Okay. So today we will be discussing natural log. Two basic rules. And that is, the derivative of natural log of x is equal to 1 over x. First rule. Second rule, the integral of 1 over x dx equals the natural log of x plus c. Don't forget those absolute value bars. So let's do some quick examples. First, so many examples will be to simply take the derivative. So let's take the derivative of the following. Let's find y prime. So that y equal natural log of 2x. So you get y prime equals the derivative of the outside is 1 over 2x times the derivative of the inside 2. You could also do this another way. This is what you have to get used to in this chapter, that there's more than one way of doing these problems. You could simplify this to y equals ln of 2 plus ln of x. This derivative is 0. This derivative here is 1 over x. And notice how they reduce to the same thing. Number 2. Y equals natural log of cosine of x. So again, derivative of the outside is 1 over cosine times derivative of the inside is negative sine x. Number 3. We have y equals sine of the natural log of x squared. Derivative of the outside is cosine. Derivative of the inside is 1 over x squared. Derivative of the next inside is 2x. Number 4. Y equals cosine of x times natural log of x squared plus 1. So you can see what I'm doing here. I'm just going through all the rules. Derivative of there's a product rule. Derivative of cosine is negative sine times secant plus cosine times 1 over x squared plus 1 times 2x. Number 5. Y equals the square root of ln of x over x. So I'm just reviewing the quotient rule now. Y prime equals the derivative of the top, which is 1/2 natural log of x to negative 1/2 times 1 over x for the inside function times the bottom. So there's my derivative of the top. Minus derivative of the bottom, which is 1 times the top all over the bottom squared. A couple other quick ones. 6y equals e to natural log of x. Remember, these cancel. So you have y equals x. The derivative is just 1. And the last problem, y equals natural log of secant of x plus tangent of x. Again, this y prime equals 1 over the whole entire inside times the derivative of the inside, which is secant tan plus secant squared. So basically the derivative is nothing new. Just you can see why this chapter is somewhat of a review. Some new rules, but just a review of the old procedures. So there's all your derivative reviews. Now let's do integration. So let's find the integral of the square root of natural log of x over x. Again, look at your rules. You don't say it. It's a natural use substitution by now. Inside function is natural log of x. The derivative is 1 over x dx, which cancels out that 1 over x there. Therefore, we're left with the integral of u du. or u squared over 2 plus c. Another problem. Integral of x squared over x cubed plus 5. Here you don't see an inside function. If you write it like this, you may see it better. Your inside function is right there. So u equals x cubed plus 5. Du is equal to 3x squared, and there the x squares cancel. So you get the integral of 1/3 times 1 over u du, which is equal to 1/3 natural log of x cubed plus 5 plus c. Next problem. The integral of 1 over 3x plus 1 squared. Again, you can see your inside function at the bottom there. So u equals 3x plus 1. Du equals 3 dx. So the integral of 1 over 3 times u to negative second, which is add 1, you get u negative 1, divide by it, negative 1/3 plus c. Again, notice this was not a natural log. That's what happens in this chapter, is all of a sudden we do a lot of natural logs, so you think everything's natural log. It's not. 1 over u is natural log. Anything else is not. The integral from 1 to 4 of x squared minus 1 over x. Just reviewing our methods now. Bring this up, we get x minus 1 over x. And these are just basic rules. X squared over 2 minus 1 minus natural log of x from 1 to 4. You plug in 4, you get 8 minus natural log of 4 minus 1/2 minus 0. Or another operator like this instead. So it's just 7.5 minus natural log of 4. Another one. The integral of 4 over x natural log of x plus 1 squared dx. Here's your inside function. U equals natural log of x plus 1. The derivative of u equals 1 over x. Again, there it cancels. So you have the integral of 4 times u to negative second du. So we integrate that, we get negative 4 u to negative 1 plus c, or negative 4 natural log of x plus 1 to negative 1 plus c. Notice the natural log here was not the actual integral, it was part of the u substitution. Let's try two more. The integral of secant squared 5x over tangent 5x. Again, this is the inside down here, it's this to the negative 1. So u equals tangent. So the derivative equals 5 secant squared 5x. Again, notice the secant squares cancel. You get the integral of 1/5 times 1 over u du, or 1/5 natural log of tangent 5x plus c. Number 7. How about the integral of tangent of x? Something we don't know. The only trig functions we know are the integral of sine and cosine. We know the integral of cosecant squared and secant squared, but not actually in the actual 6 trigonometric functions. But now we can do it. The integral of sine of x over cosine of x. So if you let this be u, so u equals cosine of x, du equals negative sine x. Therefore, it's the integral of negative 1 times 1 over u du, or negative natural log of cosine of x plus c. So in other words, the integral of tangent of x dx equals negative ln of cosine of x plus c, or natural log of secant of x plus c. And the reason why that exists is property of logs. If you bring this up as a negative exponent, you get natural log of cosine of x to negative 1, which is secant. Again, notice this is not the inverse, this is reciprocal. So I have one more problem here. I'll squeeze it up over here, just to make one point here. The integral, this is number 8, of negative 4 to negative 5 of x squared over 1 plus x cubed. U is the bottom, so the derivative is 3x squared. Cancel out the top, integral of 1/3 times 1 over u du, which is the integral of 1/3 natural log of u. I'm going to evaluate it from negative 4 to negative 5. And the key here is these absolute value bars. That's why I wanted to bring this problem up. When you put a negative, you're going to come up with a positive. That has to happen. So when you plug in negative 5, you get 1/3 natural log of 124 minus 1/3 natural log of 63. There's your answer. So, for tonight, here's your homework. It's page 259, numbers 1 to 53. I'll see you tomorrow.